morning.
We're going to talk about the scientific method and how to conduct scientific investigations. Our objectives for today. First, at the end of this, you should be able to state a clear and testable question that guides a scientific inquiry.
We want you to be able to state your hypothesis in the if-then format.
You should be able to identify independent, dependent variables, also controlled variables in an experiment.
You should also be able to identify the control group in an experiment.
And be able to tell us the difference between qualitative and quantitative data and observations.
So first, scientific inquiry almost always starts with a question or something you wonder about or something you want to find out why it happens.
Very true.
For example, your question might be, what does the color of light matter when you're growing plants? So let's say that you're growing plants inside and you want to know if the color of the light bulb you use is going to affect the plant growth.
Okay.
So question, does the color of light matter when you're growing plants?
Is this a good scientific question?
I don't know, I think it could be a little bit better. I think we can rearrange it and make it a little bit better.
Okay. What about which color of light is best for growing plants?
It's better, but not quite perfect.
Yeah, I think we still do better.
Okay. How about how does the color of light affect the growth of a plant?
That's it. Nailed it.
Good. Why is that third question the best?
Well, the first one is a yes or no question, so it doesn't lead itself to an experiment. The second question, it says which color of light is best for growing plants, but it doesn't really tell us what is best. And the third one, you can really kind of start to think about what that experiment would entail when you ask that question.
Okay. Next up, we're going to have to make a hypothesis. What's a hypothesis?
I don't know. What is a hypothesis?
It's like an educated guess.
So maybe someone could say, I think regular light is best.
Not a great hypothesis.
No.
I don't know what regular means. I think white light is best.
Nah.
A little more specific, but not great.
I think white light will make the plants grow better because it seems more like the sun.
I like that one.
Yeah. That's the best one so far.
All right. What about this one? If the plant is exposed to white light, then the plant will grow better than a plant exposed to single color lights because it seems more like the sun.
That one's way better.
Yeah, perfect.
Okay. Something important about that third hypothesis is it starts with an if, and then it says then, and then it says because.
If, then, because.
Then, because. All of your hypotheses should be formatted if, then, and because. The next thing we need to think about is how are we going to do this experiment, and it's easy to start with your hypothesis. And if we think about our hypothesis, it's almost always formatted as if I do something, then something will happen as a result.
So you can insert the if I do something with your independent variable. So in this case, it would be if I change the color of light, and then your then would be the dependent variable. Then you're going to have to decide what you're actually going to measure to see what makes the plants grow best.
So we can't just say the growth of the plant?
Well, it's not really something that you can measure. You want something more specific that you can measure.
How about the height of the plant and the number of the leaves?
I think that's perfect.
Yeah.
Great. So now that we have our variables, the color of the light as our independent, the thing that we are doing and changing, we know our dependent variable, the thing that we will measure as a response, we can go back and make our hypothesis that we thought was great even better. So now we can say if the plant is exposed to white light, then the plant will grow taller and with more leaves than a plant exposed to single color lights because it seems more like the sun.
So scientists do research before they do their investigations, and it's always wise to make sure that you understand the topic that you are studying. So beforehand, we would probably want to research, what do you think? Light?
Light.
Plants?
Plants.
Maybe how light affects plants? Yeah.
A lot of times we will tell you what your research should be. It might be an article or something to read in your textbook, but sometimes it's up to you to find out a little bit more about your topic.
And this allows you to make your best hypothesis because you want to have an informed hypothesis. Like we said, a hypothesis is an educated guess. So this research part is how you actually get educated, that you learn a little bit about the topic that you're doing your investigation or experiment on.
So Mr. Smine said it would help us make our hypothesis better. So we've revised it again to say if the plant is exposed to white light, then the plant will grow taller and with more leaves than a plant exposed to single color lights because, like the sun, white light is a combination of all light colors.
So that last part, the white light is a combination of all light colors, is something that you would have to learn in your actual research. But because you did that research, it makes your hypothesis that much better.
So your independent variable is a variable that you are changing or that you are testing. And your dependent variable always depends on your independent variable. So it's actually what you are actually measuring.
There is another kind of variable that we need to discuss though. So this time our independent variable is the color of light. We want to see if the color of light is affecting the growth of our plant, specifically the height of the plant and the number of leaves. But there are other things that can affect how a plant grows.
So these other variables are things that you want to keep the same. So you keep them the same because you want your independent variable, in this case the color of light, to be the only thing that you change. So we're going to show you some examples of some controlled variables.
So the first thing that we could talk about is the type of plant. We want to make sure that in all of our experiments we have the same type of plant.
The amount of water is something we want to keep the same. We don't want to, give the red light plant more water than the white light plant because we want to make sure that it's just the color of the light that's changing the height of the plants.
Again, the amount of water is very important. Time exposed to light, you want to make sure that you're giving each plant the same exact light. So one plant doesn't have the benefit of getting more light or less light, so you want to keep things the same.
Can you guys think of any more?
The type of soil.
Type of soil, yeah.
Distance from the soil to the light.
Temperature of the room.
Mm-hmm.
I think a good benchmark is to try to get 10 controlled variables thought of and controlled. Sometimes it's difficult.
The amount of controlled variables, the more controlled variables that you have in your experiment usually means the more reliable that your data is going to be, and the more that other people looking at your data will accept that data as being due to the fact that you change your independent variable.
Control group. So the control group is what we use for a comparison. So a lot of times you'll be doing an experiment and you see that, for instance, white light helps the plant grow better, but what are you comparing it to?
Control groups are sometimes also very difficult to figure out.
So what would our control group be?
Well, there's a couple options. We could have no light.
And that would be good because you can still control those other controlled variables, like in the same room, same amount of soil. Whereas like if you tried with regular sunlight to see if your artificial lights are better than regular sunlight, then it's harder to control those other variables.
We could use white light as our control group.
Yeah.
Does every experiment need a control group?
No, I mean, so you don't always need one.
Once you've set up your experiment and you've conducted it, you need to collect data. Data is what you are going to use as evidence to answer your question. There are two types of data that we're really going to be focusing on. There's qualitative. How do you get qualitative data?
That's something where you use your observations, your senses that we talked about the other day.
So you're describing the qualities of the thing you're observing. So like color, or
smell, aroma,
yeah, or texture, or
taste.
So I could say the flower is red.
It's a qualitative observation.
Mm-hmm.
Okay. There's also quantitative data. And what's the deal with quantitative data?
Quantitative data is usually numbers. It's a quantity. It's something that you can actually measure. So like this one, you can count up maybe the number of leaves the plant has.
Or the height that you measure would be a quantitative measurement as well.
Okay. Could we also find the mass?
Could find the mass.
So anything with numbers is quantitative data.
Yes.
Yes.
Okay. Well,
Are we done?
Let's sum it up.
All right. So you should be able to state a clear, testable question that guides a scientific inquiry. We talked about how to make your questions better, and that's it. I'm done.
We want you to be able to make sure that you can give us a hypothesis in that if, then, and usually because format.
You should be able to identify independent, dependent, and controlled variables in an experiment.
You should be able to identify a control group in an experiment, and not always. Not always.
And lastly, be able to tell the difference between qualitative and quantitative data.
There you have it.
There you have it.